If you want to know how to keep track of information within your dreams and use that information towards beneficial outcomes within your own projects, then continue watching. You'll learn exactly what's going on here and how to make this. Traditionally, a memory cell is something that's used in computing to store information. So in order to show something like this, let's go ahead and create one. Let's say we have a value that we're currently looking at, which can be something we'll call C for current. And let's have another value called N for next. We can go ahead and display these with some number displayers. I'll just move this one over a little bit. So let's say we have some sort of functionality that changes our next position and only wants to set the current to the next when it wants to. So it has two functions there. We can use a controller sensor to mimic this. We'll set it to remote controllable. We can use a signal manipulator on the buttons we want to use. So let's just use up on the D-pad for one, and we'll use X for the other one. These are both going to be set to a pulse. Just going to make this chip bigger so we have an easier time here with our space. So let's say we want every time we press up on the D-pad, we want to increase the next value by 1. We'll use up on the D-pad to power that variable modifier. So now if I play time and I press up on the D-pad, you can see it's changing it. Now, when we press X, we want to be able to take the value that's in next and store that in the current value. That's very simple to do. We'll get out two variable modifiers. One will get the value of N, and the other one will set the value of C, like this. And we only want to power that when we press X. Okay, so now if I play time, I can modify the value of N by pressing up on the D-pad, and now when I press X, it will set the current value to the value of N. From there I can continue to modify N, but we always know we still have information about the last value that was saved. Another way we can use this, a more real-world example if you will, is say we're using some sort of emission to emit things. Let's take these cubes for example. We can emit this normal looking cube, the normal color cube, at our current position while freely moving the green to emit the next position. I have the same thing here except I changed up on the D-pad. I'm going to use left and right on the D-pad, and we can use this to change the value of N. So this will set this to N, and we can add 1 and we can subtract 1. Let's copy this, and I'll change this to add 1. So when we press left on the D-pad, we want to subtract 1 from N, and when we press right on the D-pad, we want to add 1. How can we emit the cube based on that? We'll grab an emitter real quick, and I will set these to be no movement, and we'll just have one exist at a time, and it'll emit once. And now we can use this scene space transform. A transform, if you're not familiar, is a set of data that contains 3 different things. One is position, one is rotation or orientation, and the other is scale. So we're going to use the position. We can use our values and plug them into the position in order to make changes to where it's being emitted. I have the output of these signal manipulators going into this node, which I'm then going to use to power the emitter. So every time we press right or left, it will emit. And so now how do we create this position? A position is just 3 numbers, X, Y, and Z. So we can plug that in there like that. We'll grab our variable modifier and we'll get the value of n. We'll plug that into x. And there we have it. The value of n is going into the x, which is being plugged into a transform, and that is being sent to the emitter. So when we press right or left on the D-pad, we should emit something based on those values. So I'm going to use the green to signal our next position. So here we have it. Both are at 0. If I press right on the D-pad, it adds 1. If I press left on the D-pad, it goes backwards. Right, so this is going to say where our next position is. We'll do the same similar setup here, except instead of grabbing n, we'll grab c. And that's basically exactly what we want. We don't want to emit that cube. What we want to emit is our standard cube. Currently, n is constantly, or maybe just once, updating c. Right? So we still want that functionality before, where we pressed X and it updated. However, if we did that now, you can see what would happen is we'll plug X, the output of the signal manipulator from X, into there, and we'll also power the emitter. And so the problem right now is if I press right on the D-pad, they're constantly, there we go, I press X. They're both there, and if I press X again, it moves it to where the next position is, but that's not exactly what we want. What we want is we want it to emit where the current position is. So if I move next over here, the current position is still 0, and we want to spawn it at 0, right? But that's not what's happening. So in order to fix that, we can move these over here and use the object just emitted from the emitter to power this. So now what happens is we can move the next value, say the next value is here, but when we emit the original cube, we want to emit it at the position it was at. So now the current position is at 2, and so if I press X, then it emits that at 2. Right? And if I press X again without moving the next, now it's at -3. Now you may wonder why that's useful, and we can go ahead and make it a little bit more useful. If I go into this cube, I'm gonna go back into this mode. I will turn on surface snap. I'll turn the grid off for now. I'm gonna grab a circle and we'll spray paint, and I'll just spray paint an arrow onto the surface of this cube. So now we have an arrow. So if my next position is 1 and I press X, we can see the arrow is pointing towards the next position, and that's cool. However, if I move it backwards, the arrow doesn't follow, and maybe you want it to. So we can use the orientation to match based on where the next position is according to the current one. All an orientation is again 3 different things: yaw, pitch, and roll. So all we need to do is use yaw to modify based on the next position's value compared to the current position's value. We're currently grabbing the current position there, so that's great. I'll use a variable modifier to get the n value, and we'll compare that to the current value. So if the current value, or if the next value is less than the current value, then when we go to emit, we want to modify the orientation to match so that the arrow looks correct. In order to do this in a simple way, I'll use this value slider. I'll set the max value to 180, and that's just what I'll set it at. I'll also make it small. And we'll plug this into the yaw. And we'll now plug this into the orientation. However, we only want this to be on when this is true. So when the next value is less than the current value, then we want to rotate the object. If the next value is at 1 and the current value is at 0, and I press X, the arrow points towards the next position. So I'll move the arrow a little bit forward again and press X, and the arrow points in the correct direction. Now if this next position is back and we press X, the arrow turns and faces the next value. So it kind of makes it like a follower. If I increase the emitter, the max emitted at once value, say I bring it up to 5, we can see this a little better. So now if I emit, it's pointing in the correct direction. Now if I ever go back, you see the next value is at 3 and the current value is at 4. So now it'll emit at 4, but the arrow will be pointing in the correct direction. I'm going to be explaining how this concept can be used in a future video about procedural generation. So if you're interested, stay tuned and I'll see you next time.